Whenever we were in here last, we talked about how for the hexagons, the squares, and the triangles, inside of the figure we end up having 30, 60, 90, or 45, 45, 90 triangles, right? But for our pentagon and our hexagon, and our octagon that we drew on that page, we said that, those two, you would have to use trig to find the missing sides. So today we're going to do some examples where you have to use trig, since we haven't done any of those together yet. Okay, so first, here at the top of our notes, they're asking us to remember what each one of these letters is standing for in our area formula. So what does the A stand for? Very good. What does the R stand for? Good. And what does the X stand for? Half of a side. Very good. Okay, but we do use X to help us find the perimeter, which is what P stands for, right? How do we use X to help us find the perimeter? What do we have to do? Right. Double it, so multiply X by 2. That's what goes in that blank there. And then you multiply it by however many sides your figure has. Very good. All right. It then on our note says exactly what we were just talking about, that our hexagons and triangles, the inner triangles were 30, 60, 90s. For our squares, our inner triangles were 45, 45, 90s. And so we could use our tables to help us solve for the apothem, the radius, or x, whatever we would need that we weren't given. But in today's shapes, we're going to have to do something different because they aren't going to give us 30, 60, 90, or 45, 45, 90s. So, what would we say we would have to use to solve for the missing sides? Trig, right. And remember, trig is SOHCAHTOA. So it's our sine, cosine, and tangent. All right? And just as a review of what each one of those stands for, the S in the SOH stands for sine. The OH tells us its sine is equal to opposite over hypotenuse. All right? And then for the CAH, that lets us know cosine is equal to adjacent over hypotenuse. And then TOA tells us that tangent is equal to opposite over adjacent. So it's been a little bit since we've done trig. So our first two examples at the bottom of the front page are just asking us to use trig to solve missing sides in a triangle. They're not inside of our regular figures yet. We're just going to kind of brush ourselves up on how to do those. Okay? All right. So on that first triangle, the angle up here at the top is 42 degrees. Guys, this hypotenuse here is 12, and we are going to be finding the two missing sides. Okay, so we know that this is our hypotenuse because it's across from 90. This side here, what is it in reference to the angle of 42? Very good. Okay, so we're going to look for our adjacent side first. Okay, so if this is my angle, I'm looking for adjacent, and I know hypotenuse. What trig identity are we going to use? Very good. So I'll have cosine of my angle, which is 42, is equal to adjacent, which is the piece we don't know that we labeled x, over the hypotenuse, which is 12. And if I was going to try and get x by itself here, I'd need to get 12 out of the bottom of this fraction. And how would we do that? Very good. We'd multiply both sides by 12. This is the same thing as putting cosine of 42 over 1 and cross multiplying. Either way, you end up with, exactly like you guys said, 12 times cosine of 42. Make sure before you type this in your calculator that it is in degree mode. So you press the mode button on your calculator. Make sure degree is highlighted by pressing enter. Then you can type this in. So we've got 12 times cosine of 42. And what is that going to give us? 8.9. Correct. Yeah. So we'll go 3 decimal places. 8.918. All right, good deal. Okay, we are supposed to be solving for all missing sides, so we also are going to need to find the bottom piece here. And where is that in reference to the angle 42? Very good. All right, so if I'm looking for opposite, and I know the hypotenuse is 12, what should we use? Sine. Very good. And we are going to use sine. We could use tangent now that we know what this side is, but it's an ugly decimal, so we're better off to just stick with the hypotenuse and the side we're looking for. So we got sine of 42 is equal to x over 12. And again, how would I get 12 out of the bottom of that fraction? Very good. So I've got 12 times sine of 42. And I can go ahead and type that in my calculator. What are we going to get for that one? Okay, 8.029, which would be around 8.30, somewhere in there. All right, good deal. Okay. So then for my next figure over here, this bottom angle, 35 degrees. Okay, the side across from it up there is 25 meters. Okay, so if it's across from the angle, that side is the what? Opposite. Very good. Okay, so we're going to have to find the other two sides. So let's say I'm looking for this one here where the x is. What side is that in reference to the angle? Nice. So we've got opposite, and we're looking for adjacent. What are we going to have to use? Good. So we'll have tangent of our angle, 35 degrees, is equal to opposite, which is 25, over adjacent, which is x. Yes, very good. So if I have x in the bottom, how do I get it out of the bottom? All right, we're going to have to multiply both sides by x. So then I'm going to have x times tangent of 35 equals 25. And then how would I get x by itself? Very good. So x would be equal to 25 divided by tangent of 35. And approximately what are we going to get there?
85.704.
Good. Good job. All right. So that just leaves us one side to find. And which side is that? Very good. All right, so we're still using that same angle. This time we're looking for hypotenuse. Which trig identity do we want to use? Very good. So we have sine of our 35-degree angle equals opposite, which is 25, over the adjacent y, the one we're looking for. Okay, so again, we have a variable in the bottom of the fraction. How am I going to get it out of there? Multiply both sides. Good. So then I have y times sine of 35 equals 25. So how am I going to get y by itself? Divide. So we end up with y is equal to 25 over sine of 35. What am I going to get there? Very good. Okay. So now that we've kind of reviewed how we can find all of our missing pieces, now we're going to look at some of our regular polygons that will have these kind of triangles inside of them. Okay? All right. So flip it over onto the back. It says on example number 1 that we're going to be finding the apothem, the radius, the perimeter, and the area of the pentagon. They also ask what's the distance from point A to D. Okay, so here's the pentagon that they drew for you. So there's the triangle that's inside of it, enlarged. Okay, so they gave us that the radius is 4. So they already answered that part for us right here. Radius is 4. So I just have to find the other 3 terms. Okay, so first thing I need to do is figure out how many degrees one of my angles in this triangle is. If you had your notes from last time, what we did was find the interior sum, split it evenly, divide one of the angles by 2, right? The same thing as doing that would be to take the exterior sum, which is always 360. That way you don't have to always find the interior sum for every single angle. And divide it by the number of sides, which in this case would be 72 for one of the angles. And then divide 72 by 36. And instead of giving you the bottom angle here, like what we found last time, you find this angle in here, the theta, the one at the top. So that works too. If you prefer to do it where you find the interior sum and then divide that by 5 and then divide that by 2, that's fine too. That would have just given you the angle down here instead. And it would have told you that that angle was 54, right? That's what we did last time. So either way works, whatever you think is easier for you. Okay, so I do have my angle of 36 degrees. And we are looking for both the apothem and x. Well, the apothem is adjacent to that angle, right? So if we're looking for the adjacent side and we know the hypotenuse, what ratio or what identity are we going to use? Yes, good. Cosine. So I'm going to have cosine of my angle, 36 degrees, is equal to the adjacent, the side we don't know, over the hypotenuse 4. And if I'm trying to solve for A right here, what are we going to do? Very good. So then I have A is equal to 4 times cosine of 36. And what do we get for that one? Very good. All right. So now we know the apothem as well. That was one of the pieces they asked for. Next thing we're looking for is the perimeter. Well, in order to find perimeter, we got to find x, right? Okay, so in reference to the angle, x is where? Opposite. So which trig identity do we want to use this time? So we have sine of our angle 36 is equal to opposite over hypotenuse. Okay, and again, we're trying to solve for x, so what are we going to do to get the 4 out of the bottom there? On both sides, very good. So I have x is equal to 4 sine of 36. And what do we get there? All right, so now we know the apothem, we know x, and x is going to help us find the perimeter, right? Okay, so the x is this part right here, and you guys told me a second ago that to find the perimeter, what do? Very good. So we double the x by multiplying by 2 and then multiply it by its number of sides. So we now know that x is 2.351 times 2 times the number of sides, which is 5. And we end up with a perimeter of 23.51. Okay, so we know the apothem, we know the radius, we know the perimeter. Now we just plug in what we have so we can find the area. And what's our formula for area again? Nice. Okay, so I have 1/2 times the apothem, and we said the apothem was 3.236 times the perimeter, which we just said was 23.51. So I just need to multiply those 3 terms together. And what do we get there? Honestly, it all depends on what your float is set to. Y'all are both within a good range for that. Okay. So then the last thing we have to answer, they ask what is the distance from point A to point D. So A is up here, D is down here, right? Okay, well, from A to D, if that's what we're looking for, first we consider what the portion is from A to the center. So from A to the center, what would we call that? A radius, right? So we need the radius, okay? And then from the center to point D, what do we call that line? The apothem, which we said was 3.236. So if I want to know the distance from A to D, all I'm going to do is what? Add those two together. Very good. And you don't have to write down all those words there. Just something for discussion. You just need to show me that you added those two numbers together. So 4 plus 3.236 gives us 7.236. All right. Okay, let's look at example 2. Okay, example 2 does not ask you to find anything out of the ordinary. They just want us to find our apothem, perimeter, and area. So we don't have to find any extra lines or anything. Okay, they say that we're doing this for an octagon. In this octagon over here, what piece did they give us? Very good. So when I draw my triangle over here to the side enlarged, I'm going to mark that my radius is 2. Alright, so we're going to have to find the apothem. The apothem is what? Oh, sorry. First we got to find the missing angle. So you can do that the same way we did on the last problem where you divide exterior by number of sides and then half that number. And it gives you the top angle. Or you could do it the other way where you do interior sum and divide it evenly into 8 and divide by 2. That would give you this angle down here, which would be the 67.5. Either way works. You're still going to get the same answers. Your angle will be in a different spot. So let's say we are going to use the 22.5 in this corner up here. Okay. So again, we are looking for the apothem, and the apothem is what to that angle? Very good. All right, so I know the radius is 2. The radius is my what? Hypotenuse. Very good. And I'm looking for the adjacent side. So we're dealing with adjacent and hypotenuse, so we're going to want to use... Good. So I got cosine of my angle, 22.5, equals adjacent A over hypotenuse 2. And how would I get A by itself? Multiply by 2 on both sides. So I got A equals 2 cosine of 22.5. And what's that going to give us? Good job. All right, and then I also need to find x. X is what in relation to that angle? Very good. So this time we're dealing with opposite and hypotenuse, so we're going to want to use, good. So sine of our angle, 22.5, is equal to x over 2. How do we get 2 out of the bottom? Good. So I have x is equal to 2 times sine of 22.5. And then I just type that in my calculator. And what do we get for x there? Very good. Okay. So we know the apothem. That was the first thing they asked for. We can use x to help us find the perimeter. What did we say we do with x so that we can find the perimeter? Very good. So times 2 and times number of sides. So we end up with 12.24 for our perimeter. Right. And then as far as the area goes, our formula for area is and we found out that our apothem was the 1.848, and we found out that the perimeter was 12.24. So I'll multiply those 3 terms together, and what do we end up with there? So approximately 11.31 something. Depends on what your float in your calculator is set to. Should be something around here. All right, and that's all they asked for on this one. We didn't have to find any special lines. Okay. All right. All right. Everybody have that one? Will we change the slide? Yeah, that's fine, but you might want to wait. We're almost done with our notes. Okay. All right, example 3. Find the apothem, perimeter, and area of the dodecagon with a side length of 10. So this one asks for even one thing less. So we don't have to find all the sides, just enough for the area formula. Okay. So if we're talking about a dodecagon, how many sides does it have? 12. Very good. So if I'm trying to find my angle up there, theta, I would just take that 12 and divide my exterior sum, and then divide that by 2. So I know that theta is going to have to be 15. Okay, they also told us that the length of one of the sides was 10. So what would that make our x? All right, because if a whole side is 10, half of a side would have to be 5. All right, so that's the piece we have. We have this side across from our angle, which would be the what side? Opposite. Very good. Is 5. Okay, we also need to find adjacent and adjacent here. We don't have to find hypotenuse because they did not ask us for the radius. So I'm looking for my adjacent side here. I know opposite. What am I going to use as my trig identity? Tangent. Right. Tangent equals opposite over adjacent. So tangent of my 15-degree angle equals opposite, which is 5, over adjacent, which is our unknown A. Okay, and how would I get A out of the bottom? Very good. So I have A times tangent of 15 equals 5. How am I going to get A by itself? So A is equal to 5 over tangent times 15. All right, and approximately how long is our apothem? Very good. All right, so I know the apothem. The only other thing I need to find the area is the perimeter. Okay, and you guys told me that a dodecagon has how many sides? 12, and every side we know is how long? 10, so that would mean our perimeter has to be very good. All right, so our perimeter is 120. Our apothem is 18.66. I have everything I need to find the area. So area, again, we just plug in for the apothem and the perimeter. So I've got 1/2 times the apothem, which is the 18.66, times the perimeter, which is the 120. Okay. All right, we only have one more example on the notes, and this last example, all it asks for is the area. So we just need to find apothem and perimeter so that we can find the area. Okay. All right, so area of this figure, what did they give us in the picture? One of the sides. Well, if the side is 9, what's half a side? Very good. So when I draw in my triangle, I know that the bottom piece, our x, is 4.5. All right. Okay, then I need to find the measure of the angle. So how many sides does this thing have? 7, right? So I'm going to have 360 divided by 7. And then I divide that by 2 to find my theta. Alright. So, now that I know my theta, I am looking for the apothem. And the apothem is where in reference to that angle? Adjacent. Very good. Alright, so I know the opposite, and I'm looking for adjacent. What are we going to use? Good. So I've got tangent of my angle, 25.7, is equal to opposite, 4.5, over adjacent A, the piece we don't know. So how am I going to get A out of the bottom of that fraction? Multiply both sides. Very good. So I have A times tangent of 25.7 equals 4.5. And then we would have to... Very good. So we would have 4.5 divided by tangent of 25.7. What's that going to give us for the apothem? Very good. Alright, so now I know the apothem. The only other thing I need to find the area is the perimeter. And we know that every single side of this figure is how long? 9. And how many sides did we say there were? 7. So the perimeter has to be... Very good. Alright, so our perimeter is 63. Our apothem is 9.350. So to find the area, we're just going to plug those two terms in. So I'm going to have 1/2 apothem, which is 9.350, times the perimeter, which is 63. And then we just multiply those three terms together in our calculator. And approximately, what do we get there? Very good. Alright. So, now that we've gone over the ones with trig in them, we now know how to do all of them. We can do it if it's a 30, 60, 90 triangle. We can do it if it's a 45, 45, 90. Or we can do it if it's not one of our special triangles. Okay? This is the last lesson that we need to cover before our quiz. So we are going to be taking our quiz next time we are in here. Okay?